You know that AI that suggests what movie you should watch next? Well, what if I told you its origins go all the way back to ancient Greece? Seriously. In this explainer, we're going to dig into the surprisingly old story behind modern data science. So, it all really starts with this one question, a question people have been asking forever. How do we find patterns in chaos? And think about it. Whether you're checking the weather, playing the stock market, or even just using GPS to find the fastest route, you're doing exactly what our ancestors did. You're trying to find order in all the noise. So, where did they start? Well, to answer that, our ancestors looked up at the biggest, most chaotic dataset you could possibly imagine, the night sky. Yeah, the cosmos. You could say it was humanity's very first big data problem. I mean, can you imagine? The planets looked like they were just wandering around randomly. The stars, just a beautiful, glittering, but totally random mess. The universe was this incredible puzzle, right? But a puzzle with no instruction manual. But then you get these brilliant minds, people like Isaac Newton, Albert Einstein, and they did something different. They didn't just look at the universe. They figured out a way to translate its mysteries into a language that actually made sense. And this is the real breakthrough. This language, mathematics, it wasn't just for describing what was already there. No, it was a tool for predicting what would happen next. Suddenly, the chaos of the cosmos wasn't so chaotic anymore. It became a system of problems you could actually solve over and over again. And that process gave us this incredibly powerful blueprint for discovery. Think of it like a recipe for turning something you don't understand into something you do. It's basically a 3-step process, and it's powered centuries of progress. Step 1, you start with a real-world problem. Step 2, you translate that problem into the language of math. And step 3, you solve the math to reveal the hidden answer. It's so elegant, so powerful, and when you think about it, it's actually pretty simple. And right here, this is where we start to see the ancient roots of what we now call data science. I mean, this whole idea of turning a problem into a solvable equation, that goes back thousands of years. We're talking about people like Diophantus of Alexandria, the father of algebra. You could honestly make the case he was one of the world's very first data scientists. Okay, so let's hit the fast forward button. We're jumping ahead a couple of thousand years. And what's wild is that the blueprint, it's still the same. But the universe we're pointing it at, oh, that has changed a lot. Yeah, we're not just staring at stars and planets anymore. Today, we are literally swimming in a universe made of data. It's this endless ocean of information, coming from our social media, our shopping habits, even our smartwatches. This digital cosmos is the great mystery of our time. And that's the connection, right? We're facing a totally new kind of chaos, but we're asking the exact same fundamental question our ancestors did. We're hunting for the hidden patterns, the secret structures buried deep inside this ocean of data. And this is the really amazing part. To solve this modern problem, we are using the exact same intellectual blueprint that the ancients used for the stars. The tools are different, for sure, but the thinking, it hasn't changed at all. Just look at this side-by-side comparison. It makes it so clear. On one side, you've got physics. The problem, motion of planets. The method, laws of nature. The context, the physical universe. Okay, now look at data science. The problem, patterns in data. The method, statistical models. The context, the data universe. See? It's the same fundamental logic, just applied to a whole new world. And that right there is why data science isn't some brand new magical thing that just appeared out of nowhere. No way. It is built on a solid foundation of timeless mathematical ideas. You've got algebra to create structure, probability to handle uncertainty, statistics to find that signal and all the noise, and optimization to figure out the very best solution. These ideas have been around forever. So, take a look at a super simple algebraic equation. Now, you might just see a bunch of symbols, but this represents a revolutionary idea. It's the idea that you can take a messy, complicated, real-world problem and boil it down into a clean, simple structure that you can actually solve. Okay, now look at this. It might look a little more intimidating, I get it, but this is the basic equation for a modern neural network. And guess what? It is doing the exact same thing as that ancient formula. The only difference is that it's doing it on an absolutely massive scale. We're talking millions of variables, and it's constantly tweaking itself until it finds the hidden patterns in the data.
And this is such a key point. Computers didn't invent a new way of thinking. They just gave us a supercharged engine for a very, very old car. They just accelerated the process.
So, where does that leave us? What does all this mean? Well, I think it means we need to totally rethink what data science, machine learning, and AI really are at their core. Because data science isn't really a revolution, it's an evolution. It's simply the next chapter in a story that's been going on for thousands of years. The story of us, of human beings, using math to make sense of the world around us. I mean, just look at how the tools have changed. We've gone from ancient scrolls and maybe an abacus all the way to these mind-bendingly powerful supercomputers. But the core idea, that fundamental process of turning a problem into a mathematical structure, that has stayed exactly the same. So if there's one thing you take away from this, it's this. We are absolutely living in a brand new universe, a universe made of data. But we're navigating it with the same old compass that first helped us map the stars. And that compass is the timeless, powerful language of mathematics. So here's my challenge to you. The next time you hear about some crazy new breakthrough in AI, just pause for a second and ask yourself, is this really brand new? Or am I just witnessing the latest chapter in a story that began thousands of years ago? A story that's as old as human curiosity itself.